Hey everybody, this is Alex Merced from alexmercedcoder.com or alexmercedcoder.work. Now, today what I want to do is just talk about different fundamental programming language concepts. These are like the concepts that are sort of universal among many programming languages. So once you really learn one programming language, conceptually you'll have the foundation to learn other ones. It becomes a lot easier. But these are the fundamental concepts you need to understand in what you're trying to do when you're programming. Okay, so bottom line is you're trying to give the computer, tell the computer to do stuff. And you can do it by giving it instructions. Instructions are procedures, commands, And basically the instructions to do these things are algorithms. Okay, so basically you're creating an algorithm for the computer to do X and using a programming language to do so. Okay, and a programming language can be high level, low level, because at the end of the day, a computer can only understand machine language. Basically a bunch of zeros and ones, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1. And basically what happens is that's kind of hard for someone who wants to program a computer to do something really cool, like a 3D game or a really cool web application to do. Okay, because it's not intuitive for a human to read. So people have created languages that compile to machine code. And that's what's referred to as an abstraction. So basically you have languages like assembly that'll be the next sort of higher level up, but still quite low levels. You're still dealing with a language that may be not a bunch of zeros and ones, but still not necessarily very readable from a individual perspective. So languages keep getting piled upon languages, where basically either the language gets interpreted and turned into machine code on the fly, or the language might get compiled either down to machine code or get compiled to another language, then compiled into machine code, which when one language is compiled into a different language, that's referred to as transpiling. Okay, so language, to get it to actually run and tell a computer to do something, it's either got to be compiled, interpreted, transpiled, and then compiled. Okay, cool. So that's sort of how the language works. But every language has a certain way of speaking and a certain grammar. In the same way that when I speak English, I use commas in certain places, semicolons in certain places. So do programming languages, and that's referred to as the language's syntax. Okay? And then every language, one of the big things you need are data points. And a lot of times your data points may change. A lot of times you don't know what your data points are ahead of time. So you have to create ways to represent those data points, and those are referred to as variables. So think of them as little cubbyholes of data that you create. Now, different languages handle them very differently, and this has a lot more to do with the way when the language is compiled or interpreted, the memory is handled. But sometimes in certain languages, you have to declare what type of variable it is. So is this going to be a number? Is this going to be a letter? Is this going to be a whole string of letters? You'd actually have to tell the language ahead of time, so that way it sets aside the right memory. In languages, particularly JavaScript, you don't need to do that, okay? It just, when it's interpreted, it figures that out for you, okay? Which can be a lot easier for the programmer, but sometimes have a trade-off with the way memory is handled. So this is always sort of the struggle with programming languages. The easier we make the programming language, the more work the compiler or the interpreter has to do, which means sometimes it doesn't always allocate memory most efficiently, making the most efficient fast-running programs, which can really matter for programming programs that are running a lot of processes at the same time, or being run by a lot of people at the same time, using the same computer resources, like the same server. So that's where that matters. Well, a language where you have to tell it more detail, so I have to tell it sort of something like a C++, where when you declare an array, you actually have to tell them how many items are going to be in that array. You're going to allocate memory more efficiently because the compiler's not figuring it out, you're figuring it out. So this is always this trade-off between abstraction, ease of use of a language relative to how efficient it can be. So that's something to be aware of. Okay, so that's syntax, variables, and sort of the trade-off between abstraction and efficiency. Abstraction meaning how intuitive the language is structured, the level of detail I have to give. Now, here's the thing. As I create procedures, algorithm commands, sometimes I'll find myself doing the same thing over and over again. So if I'm going to be taking doing the same sort of set of steps, if I'm going to be taking the same input and generating the same output every time, it makes a lot of sense to just create a routine to do it. And these routines are referred to as functions, okay? And there are pure functions and there are impure functions. So pure functions are ones that don't change the data. So I'll put a variable, I'll put input into the function, it'll do the instructions, and then turn out a whole new set of data. So now I have two sets of data, the original and the one that's been changed by the function. That's a pure function. Doesn't touch the original data. This is sort of the idea behind what's called functional programming. This is referred to as immutability, meaning data does not get changed. You create a data point, you can use functions to create a new, to take that data and create a new data point, but you're never changing the original data point. But in most languages, you can create non-pure functions that actually change the data, where you can sit there and say, hey, take this variable and let's take the string and make it all uppercase. And now the string is all uppercase. And the old string that wasn't uppercase is gone. You can no longer refer to it because you've changed that original string. So that's mutability. So there's mutability, can change the data from its original state. Immutability, meaning you can't. And the difference being is that when things are immutable, you just create lots of versions of things. Benefit is it's easier to isolate where data is changing for the purposes of debugging. Downside is you're using more memory because you're creating several copies. Vice versa, when it's mutable, so many different things may be changing that data, it's kind of hard to figure out where it's being changed in your code. But the benefit is you're using the same amount of memory because there's only one piece of data. Okay, so that's functions and some of the trade-offs with functions. Now there's also what's outside of functional programming, there's also something called object-oriented programming. Where here you're taking a look at everything and breaking it down into objects. So let's say I'm creating a program to keep track of vending machines, okay, across the country. And every vending machine has a list of snacks that the vending machine has and the ability to buy candy from it. So if all of these vending machines work the same way, well, why would I need to create separate variables, create a separate set of details over and over again for each individual vending machine? It would be nice if I had this one sort of capsule. This was referred to as encapsulation, taking something where there's a bunch of related aspects and turning it into sort of one object and do that. So I would create a vending machine object or class. Okay, so generally the object is a single instance of a class. So a class is where I define what a vending machine is. Okay, and with a vending machine again has a list of snacks. So I'll create a property, which is a piece of data in the object, saying, okay, here are the list of snacks. And then a method, which is a function inside of the object, saying, hey, you can buy stuff from it. And now that it's defined, the class, I can then create an individual instance of the object. So I'll create the vending machine down the street that has Snickers and Almond Joy. So I change the property to say Snickers and Almond Joy, but now I can use that same vending method to buy stuff from the vending machine whenever I want. I don't have to redefine that method for each individual instance of vending machine. So you create it once and then you can duplicate it over and over again and just change the parts that need to be changed, the properties. But they all have the same actions, the same methods. So object-oriented programming is about just taking everything in your program and turning it into objects. So that way, as you need them, you just create more instances of the object. But sometimes we want to go at a higher level, okay? Because sometimes there are two separate objects. So for example, vending machines and arcade machine. They're both machines. Now there is no machine that I'll ever go to. There's no something that's just a pure, just sort of general machine. It's not an individual type of machine. But I may want to create what's called an interface. An interface is sort of a prototype for other objects to be created. So you'll never create an instance of the interface, but with the interface object, you can do what's called inherit. So objects can inherit properties in the same way you inherit certain things from your father and mother. You can inherit things from another object. So inheritance is the idea that you can create objects from objects. So I'll take an object that already exists and create a more detailed version Okay, so I can take that vending machine object and make a soda machine object that's more specific to sodas and has some extra properties and extra methods, and then create lots of soda machines. But at the same time, I can go a step level up and create the interface that's machine, and then the interface machine has certain properties and methods. That is inherited by the vending machine object that adds more properties and methods, and then that gets inherited by the soda machine object that has more properties and methods. So this way I'm only adding what I need at each level, but the thing is I'm not necessarily redoing as much of my code because that interface creates a base template. Okay, so that's essentially what's going on and that's also referred to as like polymorphism, where you're changing things. So polymorphism, encapsulation, where you're encapsulating the object, inheritance, where one object's inheriting from another, an interface, where you're creating sort of that template object that's there to create actual objects you will use. So that pretty much breaks out all of the main programming concepts you need to know for any language. So if you understood these languages in the abstract, then it's just a matter of learning the syntax so you can piece together all these tools to create the program you want to create the routine, the algorithm for the computer to do what you want it to do. So hopefully you guys found this educational. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.